Hi, my name is Wendell Rodrigues. I'm one of the authors of this work, CoforDes, an invariant feature extractor for drug pill identification. This work was developed in Brazil in Federal Institute of Ceará, IFC. The motivation and context of this work, we have about 62,000 people die daily from taking a wrong medication, a wrong medicine, for instance, a wrong pill, for instance. Some works already propose techniques for pill recognition. Most of them do analyze in controlled environments. In this work, we propose a pill feature extractor to classify it based on shape and color. We call it CoforDes. This issue has already been addressed by you in 2015, which created a pill recognition system based on 3 attributes: imprint, color, and shape. In Lee 2012, it was developed an automatic pill detection tool using gradient magnitude information on the construction of imprint descriptors. Chupao in 2015 proposed an algorithm that extracts features of printed information pills as a main approach. The works of Lee and Chupao and so on focus on the recognition using printed information. In our country, Brazil, that's not a common procedure. It's not usual. Writes information on the pill. So that's the main difference. Feature extraction has been a good approach to pattern recognition. These features are commonly used as input data for classifier. Our approach, we compare our approach using other solution, other approaches, other extractors. In this case, we show GLSCM moments, Zernick moments, local binary standards, Tamura, Ramalho, Fourier, just some extractors we compare at the end of these slides. CoforDes. CoforDes is a feature extractor of digital images that extracts invariant information of shape and color from a pill image. That's the flow. First of all, we get the image using camera just to get the pill, the image of the pill. We do a conversion. We convert to another color system using HSV system. That's better to create our segmentation image. Our algorithm is better using this color system. After that, we do the features extraction, in this case color and shape attributes, and then we do the classification using 2 databases, 2 datasets, our dataset PLBR and a USA dataset, NIH dataset for compare for testing using some approach, some classifiers to detect the correct pill using pattern recognition. That's some steps to do the segmentation. First of all, we do RGB color to HSV system color. We do this conversion. That's faster for segmentation algorithms. We detect the image edges just to recognize the background of the image. We store those points of this edge in an array, in one-dimensional array. We get the average and standard deviation from background color using the HSV system. We calculate threshold in function of standard deviation. If in this case this threshold is adaptive, maybe we can change we do some adjustments just to in function of the image, in function of the background of the images. Here we have some results. There's the segmentation, result of the segmentation. We just get the pill part, only the pill. Here we show the result of the segmentation, the region where we gonna work, okay, our algorithms of classification and extraction. Here we have some formulas just to get some information about the shape of the pill. For instance, circularity, rounding, proportion, solidity, and also reason perimeter by area, synchronized, and rectangularity also. So just some formulas, usual formulas to get this information. And here we have some images that show us which region we get the color of the pill, and also the standard deviation. For the data set, we have two data sets. Our data set is called pill BR. It's now a public data set composed of 1,000 pill images of 100 different types available in Brazil. And also we have a USA data set. It's a National Library of Medicine image data set. NIH is a set of public images. It contains JPEG with patterns optimized to recognition. Here just some samples. It's interesting to show here in Brazil data set we don't have any information about the printed information on the pill actually. So different from the USA dataset. In the USA we have some information printed on the pill that's maybe easier to detect some information compared to a pill without information. Here we have the results about accuracy and after that specificity and time. And about the accuracy, CoforDes is the best one. The green one is the best result. The blue and the orange is blue is the first one result for this kind of classifier. Here we have a mistake. It's not base, but base. Blue and orange. And the first one, the second one, best result. This case for the PUBR, our data set, and for the NIH data set is the same. It's quite similar, the result. We got the best results on both cases. The result is not so big, the difference. The difference is minimal, but it's interesting to show that we use a new approach to compare it to classical approaches. It's a good one result. It's a good one approach actually. So and that's interesting for our work. Here we have some results about specificity. Similar to previous table, we got best result also, not for the PUBR, in this case SCM average, it's best one, but CoforDes has good results also in both cases, PUBR and NIH dataset. In relation to time, CoforDes is better than other solutions. That's interesting if you plan to install our application in smartphone, for instance. It's a good solution for using solution without a good processor, high performance processor. Here we have time for a desktop solution, actually a desktop PC. It's a usual desktop PC, but that's interesting because we got some good times, small time actually to execute the extraction and classification. General analysis of the results regarding to existing methods. CoforDes obtaining better results on accuracy, specificity, and time of abstraction. Combination of color and shapes features gave us better results as well. CoforDes has proved a workable approach to extract features from drug pills images. We evaluated CoforDes using 2 datasets in 3 different classifiers and found that CoforDes got better results in accuracy, specificity, and extraction time. As contribution, on one hand, we present a new approach to compute color. On the other hand, we give a public dataset of pills available in Brazil. In future work, we plan 2 important add-ins: increase pill BR dataset towards a big national base. Also, we plan to add texture to CoforDes, not only color but texture also. It's another feature that we maybe can increase the result, increase the accuracy. And okay, that's it. Thank you. If you have any questions, feel free to ask me. I'm here. Here you have some references, and that's it. Thank you very much.